Have you ever wondered how our methods of communication evolved to what they are today? Let's take a quick journey through some pivotal moments in the history of communication systems. Communication is the process of transmitting information from one entity to another. This information can be conveyed through various means, such as mechanized, audio, or chemical signals. Mechanized communication involves the use of devices and machines, such as telegraphs, telephones, and computers. These devices often use electrical signals to transmit information over long distances. Audio communication relies on sound waves to convey messages. Human speech, music, and even animal calls are all examples of audio communication, where vibrations travel through the air to reach our ears. Chemical communication is commonly found in the natural world. For instance, plants and animals often use chemical signals, like pheromones, to send messages to each other, such as indicating danger or attracting mates. Mechanical communication can involve physical movements or vibrations, such as the drum signals used by some cultures or the tapping patterns of certain animals. Optomechanical communication blends optical and mechanical methods, often seen in technologies like laser-based systems that convert light into mechanical movements or signals. Have you ever thought about what makes up the process of communication? Let's break down the essential elements that enable effective communication. At its core, communication involves a sender, a receiver, a transmitter, a medium, and the processes of encoding and decoding. First, we have the sender, who is the originator of the message. The sender has an idea or information that they want to convey to someone else. Next, the sender encodes this message. Encoding involves translating thoughts or information into a form that can be communicated, such as words, images, or signals. The encoded message is then sent through a transmitter. The transmitter converts the encoded message into a signal suitable for transmission, which can be electrical, sound, light, or other forms of energy. The signal travels through a medium. The medium is the channel through which the message is transmitted from the sender to the receiver. This medium can be physical, like wires and cables for wired communication, or it can be wireless, using radio waves, microwaves, or optical signals. On the other end, the receiver receives the signal. The receiver's role is to capture the incoming signal from the medium. Finally, the receiver decodes the message. Decoding is the process of interpreting the received signals back into understandable information, translating it from the encoded form into a format that the receiver can comprehend. From wired connections like telephone lines to wireless ones like radio waves, the medium plays a crucial role in connecting the sender and receiver, ensuring the message is accurately delivered. A transducer is a device that converts one form of energy into another. This conversion is crucial in various systems, especially in communication, where signals need to be transmitted over distances. A transducer can convert physical quantities like pressure, temperature, force, and displacement into corresponding variations in an electrical field. This is essential because many communication systems rely on electrical signals to transmit information efficiently. Imagine you want to send a voice message. Your voice is a non-electrical signal. To transmit this voice signal over a distance, it needs to be converted into an electrical signal. Here's where the transducer comes in. When you speak into a microphone, the microphone acts as a transducer. It converts the sound waves from your voice into electrical signals. These electrical signals can then be sent to the transmitter. The transmitter processes the electrical signal and sends it through a medium, either wired or wireless, to reach the receiver. Once the receiver gets the signal, it can be converted back into sound waves or another appropriate form for the intended use. Let's delve into some fundamental components of communication systems. Attenuation. Attenuation refers to the loss of signal strength as it travels through a medium, such as a cable or fiber optic line. This loss can occur due to factors like distance, resistance, or interference. Attenuation can degrade the quality of the signal and may require amplification or regeneration over long distances. Repeater. Ever wondered how we overcome signal loss over extended distances? Enter the repeater. A repeater is a device used to regenerate and retransmit signals, extending the range or coverage area of a communication network. It receives weak signals, amplifies them, and then retransmits them, effectively boosting the signal's strength and overcoming attenuation. Signal. At the heart of communication systems lies the signal. A signal is any form of energy or information that is transmitted from one point to another. Signals can take various forms, including electrical, electromagnetic, acoustic, or optical, depending on the medium and technology used for transmission. Analog signals. Picture a smooth wave, constantly varying in amplitude and frequency. That's the essence of analog signals. Analog signals are continuous, varying signals that represent information as a continuous waveform. They're used in traditional communication systems like analog telephone lines and audio transmissions. Digital signals. Now, let's flip the switch to digital signals. Digital signals are discrete, binary signals that represent information as a series of discrete values, typically zeros and ones. They're the backbone of digital communication systems, offering improved noise immunity, easier signal processing, and greater flexibility in encoding and transmission. A quick dive into the history of communication. In 1835, Samuel Morse, along with Alfred Vail, developed the Morse code system. This binary method of communication, which encodes text characters as sequences of dots and dashes, became a crucial advancement for telegraphic communication. In 1876, Alexander Graham Bell was awarded a patent for the invention of the telephone. This groundbreaking device transformed communication by allowing voice transmission over long distances. By 1895, Guglielmo Marconi successfully demonstrated the transmission of wireless telegraphy, marking the beginning of the era of wireless communication, which would eventually lead to the widespread use of radio and later, television. In 1936, the British Broadcasting Corporation, BBC, began the world's first regular high-definition public television broadcasting service from Alexandra Palace in London. This was a significant step forward in mass communication and entertainment. The year 1955 saw the development of the first transistorized computer, TRADIC, Transistorized Airborne Digital Computer, at Bell Labs. This key advancement in computer technology made computers more reliable and paved the way for modern computing. In 1968, the Advanced Research Projects Agency Network, ARPANET, the precursor to the Internet, was developed. The first successful message was sent over ARPANET in 1969, laying the foundation for the modern Internet. 1975 brought the introduction of the Altair 8800, widely considered the first personal computer. Featured on the cover of Popular Electronics magazine, it ignited the personal computer revolution and led to the development of home computing. Finally, in 1981, IBM introduced its first personal computer, the IBM PC. This machine became highly influential in the personal computing industry, setting standards for hardware and software that are still in use today. And there you have it, the essential components of communication systems explained. But don't go just yet. We've only scratched the surface. Be sure to subscribe for part 2, where we'll dive deeper into the fascinating world of communication technology, exploring more components and uncovering even more insights. Stay tuned and keep exploring with us.